Find the equations of the two tangents that can be drawn to the circle x squared plus y squared minus 2x minus 4y minus 5 is equal to 0 from the point 6 minus 3 outside the circle. So the circle C has a centre of 1, 2. So what I did was I took the coefficient of x, which is minus 2, I halved it and changed the sign to get 1. I took the coefficient of y, which is minus 4, I halved it and changed the sign to get 2. Next, I'm going to work out the radius. So I'm going to use this formula, the square root of g squared plus f squared minus c. So I'm going to take the 1 and I'm going to square it. So I've got 1. I'm going to take the 2, I'm going to square it, so I'll get 4. And then I've got minus c, so it's going to be minus 5, which is plus 5. So I get the square root of 10. So I have my centre and I have my radius of the circle. So if we draw out an xy axis and we plot the point 1, 2, and we have a radius of root 10 and draw our circle, we can see the circle very clearly here. So remember, we're trying to find the equations of two tangents, so two lines that can be drawn to the circle from the point 6 minus 3 outside the circle. So if we go across to the point 6 minus 3, plot a point, and we draw one tangent and label it T1, and draw the other tangent and label it T2. So remember, a tangent meets a radius at a right angle. So we have a right angle, perpendicular, and another set of right angles over here. So right angles are 90 degrees or perpendicular angles. So you weren't required to actually draw it out, but it is easier to see what's going on if you do draw it out. So we're going to let the slope of a tangent be m. Then the equation of one of the tangents is going to be y plus 3 equals m times x minus 6. So I've used the equation of a straight line formula, and I have used the point 6 minus 3 for my x1, y1, and I'm just letting m be the slope. So I multiply out my brackets, so I get y plus 3 equals mx minus 6m, and then I rearrange to get everything on the left of the equal sign. So I have mx minus y minus 6m minus 3 is equal to 0. So this is the equation of one of the tangents. As this line is a tangent, the perpendicular distance is equal to the radius. So the perpendicular distance from the point, which is the centre, to the line, which is a tangent, is equal to the length of the radius. So what we're going to do is use the perpendicular distance formula, which is the distance from a point to a line formula, which is the modulus of ax1 plus by1 plus c, all divided by the square root of a squared plus b squared. And we're going to let that equal to the radius, which remember we found out to be root 10. So we need to decide on what's going to be our a, b and c. So the coefficient of x is going to be the a, so that's m. The coefficient of y is going to be the b, so that's minus 1. And the c is going to be the constant at the end, so that's going to be 6m minus 3. So the a is m, the b is minus 1, and the c is minus 6m minus 3. Next we need to decide on the x1 and the y1. So the x1 and the y1 is going to be the centre of the circle. So the 1 is the x1 and the 2 is the y1. So the 1 is x1 and the 2 is y1. So next we just substitute into the formula. So ax1 is going to be m multiplied by 1, which will just give us m. by1 is going to be minus 1 multiplied by 2, which will just give us minus 2. And then the plus c is going to be minus 6m minus 3. And remember, we have our modulus symbol at the start and at the end. This is all divided by the square root of a squared plus b squared. So remember, the a is m, so we get the square root of m squared plus b squared, which is minus 1. So we get minus 1 squared. So this represents the perpendicular distance, and that's all equal to the radius, which is root 10. So next we simplify. M times 1 is 1m, and 1m minus 6m is minus 5m. minus 2 minus 3 is minus 5. So we get minus 5m minus 5. Now since we have a fraction on the left of the equal sign, I want a fraction on the right of the equal sign, so I'm going to change root 10 to root 10 over 1. And I'm going to cross multiply and solve. So remember, I got as my numerator minus 5m minus 5, and that multiplied by 1 is just going to be minus 5m minus 5. Don't forget your modulus symbol. Next, I'm going to multiply this denominator by the numerator, which is root 10. So minus 1 squared just becomes 1. So I have the square root of m squared plus 1. And that's all multiplied by root 10, so I just stick them together. So I get root 10 stuck onto root m squared plus 1. So now I have my equation. I have no fractions anymore. So now I just need to simplify. So in order to get rid of the roots, I need to square both sides. So minus 5m minus 5 squared just becomes minus 5m minus 5 squared. Root 10 squared gives me 10. And then root m squared plus 1 squared just gives me m squared plus 1. Very important here, the root 10 and the root m squared plus 1 were stuck together. So we need to bring down brackets because we're going to have to multiply out the brackets. So very important to remember the brackets there. Minus 5m minus 5 squared gives me 25m squared plus 50m plus 25. 10 by m squared is 10m squared, and 10 by 1 is 10. Next, I bring everything over the equal sign. 25m squared minus 10m squared is 15m squared. Still have my 50m, and 25 minus 10 is 15. Next, I can divide across by 5, getting 3m squared plus 10m plus 3 is equal to 0. Now at this point I can use the minus b formula, the quadratic formula, or I can factorize and solve. So I factorize and I solve, and I get m equals minus a third, or m equals minus 3. So now I have 2m values. Remember, m represents the slope, and I need to go back and have a look at my question. My question said find the equations of the two tangents that can be drawn to the circle from the point 6 minus 3 outside the circle. So remember, we're trying to find the equations of the line T1, the tangent, and the line T2, the other tangent. We've worked out the slope of one of them is minus a third, and the slope of the other one is minus 3. So remember, we already have the equation of the line, and it is mx minus y minus 6m minus 3 is equal to 0. So what we have to do is swap the m's for minus a third, and then separately swap them for minus 3. So when m is equal to minus 3, the tangent is minus a third x minus y plus 2 minus 3 is equal to 0, which we can simplify to x plus 3y plus 3 is equal to 0. Or when we have m is equal to minus 3, we get the tangent to be minus 3x minus y plus 18 minus 3 is equal to 0, which simplifies to 3x plus y minus 15 is equal to 0. So these are our equations of the tangents.